Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover some applications of systems of linear equations. We'll do this part one. I'll do a couple different applications. We'll do curve fitting, we're going to do network analysis, and then maybe Kirchhoff's laws as well. So first one being curve fitting. So for curve fitting, if you have n solution points, say the first solution point, second solution point, all the way to the nth solution point, what I mean is I'm going to have an x1, y1 for the first solution point, x2, y2 for the second solution point, and so on, then this will define an n-1 degree polynomial that has these as solution points. So we can kind of think about it this way, like in an algebra class, like if I have 2 points, what does that determine? Well, if you have 2 points, what that does is that determines in a unique line. Now, 2 points is going to give you a degree 1 polynomial because that's a line. Now, if I have 3 points, this is going to determine a unique parabola. If I have 4 points and so on, this is going to be unique cubic. So we're going to start out with our parabolas because we already know how to do lines, but this technique will work for lines, and it really technically is just an expansion of what you've done really in an algebra class. So determine a polynomial, p of x. So I'm actually saying that this is a second-degree polynomial because what I have 3 solution points. So the way we do this is, for this first solution point, 1, 4, what I know is this is going to be, the x value, this is going to be the y value. So it has to be a solution to this. So, this being the y value, it says that, I'm going to write it this way. Actually, I'm going to say that this is equal to p of x. So let's do it this way. So if I have, an x comma y, this is going to be equal to a naught plus a1x plus a2x squared is equal to our y value, this being the y. So if I have the point 1, 4, well, this is a naught plus a1 times 1 plus a2 times 1 squared is equal to 4. If I have the solution point 2, 0, and then a naught plus a1, remember, everywhere there's an x, I'm putting a 2. Everywhere there's a y, I'm going to plug a 0. So this is going to be 2 plus a2 times 2 squared is equal to 0. And then for the last point, the same thing. X is equal to 3, y is equal to 12. So everywhere there's an x, I'm going to write a 3. Everywhere there's a y, I'm going to write a 12. So a naught plus a1 times 3 plus a2 times 3 squared is equal to 12. Now, notice that once I do these powers and write these things as coefficients, you have nothing more than a system of linear equations where your solution points are going to be, where your solutions are going to be these coefficients. So even though this is a quadratic equation, when I simplify this particular expression, you're going to have, it's going to be a linear in nature. So let's write this. I have a naught plus 1a1 plus 1a2, because that's what 1 squared is equal to 4. The next one I'm going to have a naught, now there's still 1 in front of those as well, so these all have coefficients 1. Plus 2a1, 2 squared is going to be plus 4a2 is equal to 0. And similarly, 1a naught plus 3a1 plus 9a2 is equal to 12. And what we can do is we can rewrite this as a matrix: 1, 1, 1, 4, 1, 2, 4, 0, and then 1, 3, 9, 12. So I will row reduce this for this particular example. Maybe in part 2 and part 3 we won't row reduce, we'll just use our calculators, but we'll row reduce this one. And if you want to go back to the row reduction videos and just skip ahead to the solution, if you already know how to do this, we'll kind of explain where they come from. So our goal is to make it a 1, 0, 0, 1, 0, and then a 1, right? If we can. So in order to do that for this, I'm going to, to make these things zeros, I'm in column 1, so I have to use row 1. So minus row 1 plus row 2 is going to be my new row 2. And I have minus row 1 plus row 3 is going to be my new row 3. So that's going to make those things 0. So I have the matrix 1, 1, 1, 4, So this is going to be 0. Minus 1 plus 2 is going to be 1. Minus 1 plus 4 is going to be 3. Minus 1 times 4 is minus 4 plus 0 is going to be minus 4. And then for this one, minus this plus this is 0. Minus 1 plus 3 is 2. Minus 1 plus 9 is 8. Minus 1 times 4 is minus 4 plus 12 is going to be 8 as well. All right, now our job is to go ahead and make this a 1, which it is, and now make this a 0. Now again, I'm in column 2, so I'm going to use row 2 to do that. So minus 2, because I need to make this opposite side of that. Minus 2 row 2 plus row 3 is my new row 3. And that is going to give us this matrix. A 1, 1, 1, 4, 0, 1, 3, minus 4, and this is going to be 0, minus 2 times this plus this, minus 2 times this plus this is also 0, minus 2 times 3 is minus 6 plus 8 is 2, minus 2 times 4 is going to be 8 plus 8 is 16. Perfect. And then now you know, I'm going to do this really simply. So when we do this, we can now change this to a 1 comma 8. We know that I can do minus, well, 1/2 row 3 is going to be my new row 3. And what that's going to do is it's going to change this into a 1 and this into an 8. All right, now I need to make these things 0. And since I'm in column 3, I'm going to use that row 3, which is that 1. So in order to do that, I'm going to go, in order to get rid of that, it's going to be minus row 3 plus row 1 is my new row 1. And in order to make, this is 0, again, I'm in column 3, so I have to use row 3. So this is going to be minus 3 row 3 plus row 2 is my new row 2. And what we're going to get here is row 1 and row 2 are changed. Row 3 is going to be the same. So 0, 0, 1, 8. And now using this, minus this plus this is going to be 1. Minus this plus this is going to be 1. Minus 1 plus 1 is going to be 0. That was the goal. Minus 8 plus 4 is going to be minus 4. Now for the next one, minus 3 times 0 plus 0 is going to be 0. Minus 3 times 0 plus 1 is going to be equal to 1. Minus 3 plus 3 is going to be 0. And then minus 3 times 8 is minus 24. Minus another 4 is minus 28. All right, now we're almost done. The last thing I have to do is take care of this one. Now with doing that, we know that I'm in column 2, so I have to use row 2. So minus row 2, I have to make this opposite of this. So minus 2, so just multiply by negative 1, plus row 1 is my new row 1. And what we're going to get here is, I know row 2 and row 3 are unchanged, so I might as well just write those down. But my new row 1 is going to be, well, minus this plus this is 1. Minus this plus this is 0. This plus this is going to be 0. Minus 28, minus 28 is going to be 28. Minus 4 is going to be 24. All right. So what that gives us, beautiful, just make sure I got the right answer. What this says is, this is your A naught, A1, A2, but this just says A naught is equal to 24. This says A1 is equal to minus 28, and this one says A2 is equal to 8. So what that tells us is, remember that this, I'm trying to find that quadratic equation that has these as solution points. And if I have the correct A naught, A1, and A2, which is right here, I know it's definitely going to pass through those 3 points. So therefore, our solution says P of x, or you can say y if you want, is equal to A naught, which is 24, plus A1, well, A1 is minus 28, so minus 28 plus a minus 28, x, and then A2 is plus 8x squared. And you can check, plug in x equals 1. You'll notice this will say 4. Plug in x equals 2 for this. You'll notice it'll spit out 0. And then x equals 3, it'll spit out 12. So I can guarantee that, this right here has those as solution points. So if you like the content, please subscribe.